45 million gallons. That is how much water flows through the original Croton aqueduct system into New York City every single day. Not through the modern tunnels built in the 20th century to replace it, not through the newer infrastructure that was supposed to have made the original system obsolete generations ago. Through the original system, the one built between 1837 and 1842. Using hand labor, black powder, and engineering principles that the engineers applying them considered experimental enough that they could not guarantee in advance that the system would work as designed. A system of brick-lined tunnels, stone gatehouse structures, and terminal reservoirs, constructed when New York City's total population was under 400,000 people. Designed with dimensions that its builders chose, not because those dimensions were appropriate for the city as it then existed, but because the builders calculated that the city would eventually grow to a scale that would require them. The engineers who made those calculations were right. The city grew to match what they had built for. And then it grew beyond what they had built for, and the systems that were constructed to replace what they had built have never been completed. So the original system, designed in the 1830s for a city that no longer exists in any form that its designers would recognize, is still carrying 45 million gallons of water per day into the largest city in the United States. Not as a backup, not as a supplemental source, as a functioning primary component of the infrastructure that keeps New York City alive. And the tunnels that were built to replace it have never been inspected since the day they entered service. I found this while researching the underground infrastructure of American cities. Following the pattern I had identified across multiple investigations of systems that were built to exceptional standards, operated for far longer than anyone who had alternatives would have chosen to rely on them, and maintained in ways that revealed the gap between the official story of continuous institutional competence and the actual story of institutional choices made when maintenance conflicted with other priorities. New York's water system is the most consequential example I found, not the most dramatic, not the most deliberately concealed, the most consequential, because its failure would not be a historical footnote. It would be a catastrophe of a kind that the city has no plan for managing. The official story of New York City's water supply is a story of continuous development that has successfully kept pace with the city's growth from a small port town to the largest urban concentration in the country. The Croton system was built in the 1840s because the city's existing water sources, local wells and cisterns that drew from an increasingly contaminated water table, had become inadequate and dangerous. The system brought fresh water from the Croton River in Westchester County through 41 miles of brick-lined aqueduct into a distributing reservoir at what is now the site of the main branch of the New York Public Library on Fifth Avenue. It worked. The city grew. The system was expanded. The Croton watershed was developed further. Then, the Catskill system was added in the early 20th century, bringing water from reservoirs in the Catskill Mountains through a new aqueduct. Then, the Delaware system was added in the mid-20th century, extending the watershed further into the Delaware River basin. Today, New York City draws water from a watershed covering approximately 2,000 square miles through a network of 19 reservoirs and 3 controlled lakes, connected by tunnels and aqueducts and distribution infrastructure of extraordinary scale and complexity. That story is accurate in everything it describes. What it does not describe is the condition of that infrastructure. City Water Tunnel No. 1 was completed and entered service in 1917. City Water Tunnel No. 2 was completed and entered service in 1936. Together, these 2 tunnels carry the majority of New York City's daily water supply through the bedrock of the city to distribution points throughout the 5 boroughs. They run at depths that reach hundreds of feet below street level. They have diameters large enough for a person to walk upright through them, and they have never been shut down for inspection since the day they entered service. Not once, not for a week, not for a day, not for an hour. The reason they have never been inspected is straightforward and deeply uncomfortable. Shutting down either tunnel for inspection would require the tunnel's entire flow to be handled by the remaining infrastructure. The engineers responsible for evaluating whether that is possible have consistently concluded that the remaining infrastructure cannot reliably carry the load, that if Tunnel 1 were shut down, the combination of Tunnel 2 and whatever other water delivery capacity the city possesses would not be sufficient to reliably supply a city of 8 million people with the water they need to survive. And so the tunnels remain open. And so the tunnels remain uninspected, year after year, decade after decade. The condition of the tunnel linings is unknown. The condition of the joints between tunnel sections is unknown. The condition of the gate chambers and valve mechanisms that would need to function correctly for the tunnels to be safely taken offline is unknown. The valves that would allow sections of the tunnels to be isolated, which would be the first step in any inspection process, have not been operated in so long that many of them are believed to be physically frozen in place, impossible to turn without risking structural damage to the valve housing, which would mean that attempting to inspect the tunnels might result in permanently disabling the mechanisms that would be needed to shut them down in an emergency. City Water Tunnel Number 3 was begun in 1970 specifically to solve this problem. The plan was to build a third tunnel with sufficient capacity to carry the full load while either of the existing tunnels was taken offline for inspection. The third tunnel was expected to reach sufficient operational capacity to enable this by approximately 1980. As of the research for this investigation, Tunnel 3 has been under construction for more than 50 years. Portions of it are operational. Sections of the Bronx and Brooklyn are now served by it, but it is not complete. The portions of the system that would allow it to carry enough of the load to take either Tunnel 1 or Tunnel 2 offline do not yet exist, and Tunnel 1 entered service in 1917. Now, here is where it gets strange. The original 1842 Croton Aqueduct is not the oldest functioning component of New York's water infrastructure. Beneath the streets of Lower Manhattan, there are water mains that predate the Croton system entirely. Cast iron pipes installed in the 1820s and 1830s, and in some documented cases, wooden pipe sections that date to an even earlier period. They are still in the ground. They are not carrying significant volumes of water. They have been bypassed by successive generations of newer infrastructure, but they have not been removed, because removing them would require excavating streets that have been built, rebuilt, and built again above them. And the cost of doing that has never been judged worth the benefit of eliminating infrastructure that is not currently causing problems. The logic that has governed New York's water infrastructure management for nearly 2 centuries is precisely this. If it is not currently causing problems, do not spend the resources to address it. If it is causing problems, fix the specific problem without undertaking the broader work that addressing the underlying cause would require. If fixing the specific problem is not possible without disrupting the service that the problematic infrastructure is providing, work around it. The original 1842 Croton system is still carrying 45 million gallons per day, not because anyone decided to keep it operational. It is carrying 45 million gallons per day because the systems built to replace it are not finished. Because the logic of managing the existing system one crisis at a time rather than replacing it comprehensively has been applied continuously for nearly 2 centuries, and because the cumulative result of that logic is a water delivery system whose oldest components are approaching 200 years of service and whose critical load-bearing tunnels have never been inspected. The engineers who designed the original Croton system made a specific set of choices about how to build it. They chose materials based on durability rather than cost. They chose dimensions based on the city they expected rather than the city that existed when they were designing. They built the gatehouse structures in stone rather than wood, at substantially greater expense because they expected those structures to be in service for a very long time. Those choices have been vindicated by the simple fact that the infrastructure those choices produced is still functioning. Nearly 2 centuries after it was built, in a city that its builders would not recognize, carrying water to a population 40 times larger than the population it was designed for. The choices made by the engineers of the 20th century were different. The systems they built were designed to a different standard, faster to construct, less expensive to build, adequate for the service conditions of the period in which they were built, but not designed with the same margin of durability, not built with the same expectation that they would need to last for 2 centuries without inspection. And now, because the replacement systems are not complete, the city is dependent on both. On the 19th century infrastructure that was built to last but was expected to be superseded, and on the 20th century infrastructure that was built to supersede it but was never inspected. The engineers of 1842 built something that would outlast their expectation of its service life by a margin that they could not have predicted. The engineers of 1917 built something that is still in service without inspection more than a century after it was built, carrying water to a city whose survival depends on its continued functioning. The two situations are not equivalent. The 1842 infrastructure was built to a standard that has proven adequate for the duration it has served. The 1917 infrastructure was built to a standard that was never expected to be tested over the duration it has now served, because it was supposed to have been inspected and repaired, and in some sections replaced, long before this point. The 45 million gallons still flowing through the 1842 system flow because the 1842 system was built to last. The unmeasured volume flowing through Tunnel 1 every day flows through a structure that nobody has been inside since 1917. That may be in perfect condition, or that may be in a condition that nobody currently alive knows anything about, because the mechanism for finding out has never been built, because building that mechanism would require completing Tunnel 3, and Tunnel 3 has been under construction for 50 years. The water still flows every day, 45 million gallons through a system built in 1842, and an unknown volume through tunnels built in 1917 and 1936 that have never been inspected, and a partially complete third tunnel that has been under construction since before most of the people who live in New York City today were born. This is what the infrastructure that keeps one of the largest cities in the world alive actually looks like. Not the official story of continuous competent development meeting the city's needs, the actual story of original infrastructure outlasting its expected service life because the systems built to replace it have never been completed, and critical load-bearing infrastructure operating for over a century without the inspection that would reveal its current condition. The water still flows. For now. But the question of what condition the tunnels carrying it are actually in is a question that nobody has been inside to answer, and the system for answering it has been under construction for 50 years. If you want more videos like this, make sure to subscribe to the channel. I'll see you in the next one.